In the first part of this video, we saw how to make variables of type color. Once you've created a color variable, it's stored in some weird internal format. But suppose you'd like to get back the red, green, and blue components of a color variable, or maybe the hue, saturation, and brightness values. This video shows you how to get that information. One way to think about all of this is by analogy. Suppose that someone wants you to make a shirt for them. So you start out by making the pieces of the shirt. And here the pieces of the shirt are like our red, green, and blue components. And then you sew them together and you make a shirt. And that's like a color variable. Then someone comes along later and says, I want a much bigger shirt. I want a shirt of twice the size. You can't just grab the original shirt and pull it to twice the size because it'll just rip and tear. To make a double-sized shirt, what you have to do is to take the first shirt apart into its pieces, measure each piece, then make a double-sized version of each piece, and sew those together. And this is exactly what we do with colors. So we don't manipulate colors. We can hand them off to fill and stroke and background, but we don't actually add to them or multiply them. We don't do anything with colors. In order to change a color or manipulate it in some way, we do just like what we have to do with the shirt. We take it apart into its pieces, we change the pieces, and then we put the pieces together to create a new shirt. So how do we take color apart into its pieces? Well, processing gives us 3 routines for doing that. If we start with a color variable and we want to get back the red, green, and blue values, there are 3 calls. The first is red. Red, open paren, name of a color variable, close paren. This little expression gives us the red component of the color. And we can just assign that into a variable like a float. If we want to get the green, we call green. Open paren, CV, close paren, and it extracts the green component. And here I'm using CV because that's the name I gave to the variable. It could be green of dirt or green of purple flower, whatever the name of the color variable is. And of course, there's blue. And we can pull out the blue component and assign it to a variable. And I'll show you code for this in just a moment. So I want you to think of this as the way we manipulate colors. We pull it apart into red, green, and blue using this technique, manipulate those red, green, and blue values, and then put them back together again to make a new color. This also shows us something interesting. The words red, green, and blue are reserved by processing. If you have a color in your program and it's kind of a red color and you think, oh, I'll give this variable the name red, avoid that temptation. The words red, green, and blue are reserved words in processing. Just like fill and setup and background, they're the words that processing uses to do its work. It's a bit of a shame because they're such convenient words. I mean, all the time you're creating colors and you might have a yellow color and a purple color and an orange color and then a red color and you want to call it red. But don't do it because you're going to conflict with the fact that red is a reserved word. And so what you find people doing fairly frequently is they write something like red color, or they somehow change the word red so that it is not just the word red. I've seen people create variables named my red or special red. You can call it anything you want, just don't call it red or green or blue. So let me show you this in action. If we want to create a dirt color, we've seen all we have to do is this. We declare dirt to be a color variable and we assign it a color value. Now, if we later want to get the red value out, this is all we have to say. Red, open paren, dirt, close paren is the red value. In this case, it would be 170. And we just stick that into a variable, which I'm calling dirt red. We can do the very same thing for green and blue. You'll notice here that I'm writing red, green, and blue for my variables.
I'm keeping them all at 3 letters. I do this all the time because this way everything lines up vertically very nicely. My red, green, and blue variables are all 8 letters long, 7 letters plus an underline. You don't have to do that. That's my personal little thing. Some people do it, some people don't. If you want to spell it out, dirt green, dirt blue, absolutely you can. You can call these variables anything you want. In addition to red, green, and blue, if you want to get the opacity value, you can do that by calling alpha. And that returns to you a number between 0 and 255, representing the transparency of the color, as we discussed in the transparency video. If you don't assign a transparency explicitly, like we don't in the very first line here, processing assumes it's an opaque color and gives it an alpha of 255. So if I ran this last line, dirt underscore opa would have the value 255. So let's use these things to do the equivalent of making a larger shirt. In this case, I'm going to take a pink color like this, and I want to create a darker pink color. So again, summarizing what we have here, we're declaring a color variable named pink, and I'm giving it a red, green, blue value. Now, assume I got this thing from the web, or this color definition is 100 lines behind me, and I don't know what the red, green, blue values are, but I want to make a darker pink color out of this. Well, I know what to do. I can use red, green, and blue to pull the color components out. So let's actually write some code to do that. I want red, green, and blue of pink, so I have to give that to each of these little things in parentheses. And now I'll create some variables to hold these values. Red, green, and blue. Again, I'm using my funny little 3-letter shorthand for that. And of course, we need semicolons at the end. So now we're set. Red val, green val, and blue val hold the numbers 200, 137, and 178, the red, green, and blue components of pink. Well, now we can create a new color using those. So I'll tell you what, let's push these up out of the way and make a new dark pink color. And I'll do that by declaring a variable named dark pink and assigning it the color value of red val over 2, comma green val over 2, comma blue val over 2. Just dividing them all by 2. And we'll get sort of a dark pink color. We've covered a lot of information in this one video, so let me summarize it for you. To create a color variable, all we have to do is declare it to be of type color and then assign it a value. And the most common way to assign it a value is you just say color, red, green, blue. But you can use any of the other color making techniques we've seen. You can hand it color of just a single number, and it will use that for both red, green, and blue. And you can give it the color RGB with alpha. If you're in HSB mode, the first 3 numbers here, RG and B, would be interpreted as hue, saturation, brightness instead of red, green, blue. To pull a color apart into pieces, we call red, green, and blue, and they take the name of the color immediately after in parentheses. And if the color happens to have an alpha value, well, we can call alpha as well. If you want the hue, saturation, brightness values, those exist as well. You just call hue, saturation, and brightness. A nice thing about color variables is that they don't care what mode you were in when you made them or what mode you're in when you make these calls. A color is a color is a color as far as processing is concerned. So you can call red, green, blue, alpha, hue, saturation, and brightness on any color at any time, and you will get the right value. It doesn't care what mode you're in. The only time processing cares what color mode you're in, as far as this slide is concerned, is the top 3 lines. In fact, just the second and third lines, because those are the ones where RGB would be interpreted as hue, saturation, brightness. This video has all been about how to create and manipulate color variables. But I haven't talked about why they're so incredibly useful. That information is covered in the next video using color variables, where I will show you that they are so incredibly handy and so useful for doing all kinds of things that you will embrace them and come to love them.